everybody. A very warm welcome to all our attendees that are on the webinar this morning. Thank you so much for joining us. Please feel free to interact with us via the chat panel if there's anything that you want to contribute or there's any questions that you may have. I'd like to introduce our speaker this morning on the webinar. We have Nuruddin Liani, and Nuruddin is a structural engineer that's based in Morocco. Nuruddin, welcome with us. I'm going to hand over straight to Nuruddin so that we can get started, and Nuruddin can give us an overview of context and survey and context capture.
Thank you, Gillian. Hello, everyone, and welcome to this webinar. In this webinar, we are trying to show you a great workflow we're trying to promote across all the continent that supports survey and context capturing. So without any further delay, let's just start. A quick introduction about myself. I'm 31 years old, based in Morocco, as my colleague said. I have a structural engineer from training. I live in Morocco also, and I have a 10-year experience in building area. I have been working in engineering office for almost 7 years before joining IDEA Technologies as the regional technical account manager for all 3 regions: Anglophone, Francophone, and South African regions. I have been traveling quite a lot in many countries in the continent, visiting all the regions at the same time. And today I'm going to show you how we can leverage, or let's say level up our knowledge about context capturing and surveying for vertical and complex building. So what is this vertical and complex building, surveying context capturing we're talking about? It is mainly based on surveying. It is a science that enables us to measure and represent every shape and visible detail that we can see on a site on our Earth, and transform it into a drawing, a 2D drawing or a 3D modeling. So this has been a science that has been used for quite a long time, using some traditional tools such as levels, theodolite. Recently, we're talking about total stations, robotic total stations. And now we're trying to promote some new technologies that cut the time spent by really a lot. We're talking about months comparing to days or weeks, if I can say. And this is really quite new and interesting for surveying, especially we're talking about building here. It's not general surveying. So what we want to really talk about in this webinar is that we're talking about surveying a site using traditional equipments, theodolite, levels, and other equipments. And as you can see, we need 2 operators at least in order to do the surveying. And we need to represent all this contour and shapes in a CAD solution, for example, AutoCAD or any other CAD solution. And as you can see in the picture, we have a drawing that represents all the elements or all the objects or all the shapes that we have surveyed on the site. Then we are just going to share this data with other project stakeholders.
Nuruddin, can I ask you, how can they share this data with other stakeholders? Are you going to be able to tell us that?
Yes, thank you for this question, Gillian. The way we are trying to share the data currently is only with traditional communication tools, by email, on a USB stick, on a CD. We are just trying to use some ordinary sharing tools. Some customers try to use cloud-based solutions such as Dropbox, and other cloud-based solution just to upload the document there and share the link with other stakeholders. But until now, we're just trying to use some basic ways to share this data. So the difficulties that our surveyors are facing right now is that this method requires two operators, at least, as you can see in the picture, one manipulating the total station, one holding the target, and it's only point-by-point surveying. We just need to place the target in a specific point, then survey the data or the coordinates, you can say, with the total station. And it is really time consuming. If we are talking about a building, you need each time to place the target in a specific point in order to survey it, then move the target to the next point. And we are talking about no accuracy. I'm not talking about the accuracy of what is the exact coordinate of this point, but we are talking about if we are surveying, for example, 2 points in a line, we don't know what if we have any specific element between these 2 points. We don't have any information about it. We need to survey it with another separate operation. And this is really the main issue. We need to survey each point, each element with a single operation. And we need to repeat this operation as many singularities, if I can say, as we have in a building. Imagine we're talking about a complex building that we need to survey. For example, it will really take a lot of time to survey all the characteristic or the singular points within this method. If you can see, for example, in these drawings, imagine all the time that we need to spend if we want to restitute or redraw these drawings for an existing building. Imagine it has been built many years ago, and the customer, the owner, doesn't have the drawings anymore, and he wants at least to have a drawing for his existing building, so that if he want to do facility management, for example, or if he want to renovate his building, he needs at least the drawing in order to work on it. So if we want to survey a building like that, we really spend a lot of time trying to survey it, and it's really painful and difficult. Also, whenever we come back to the office to draw these kind of drawings, and we realize that we are still missing some specific points, we need to come back to the site and do the surveying once again. And it is really, really time consuming and difficult.
Nuruddin, I will imagine that this technique can be a lot more difficult if you're surveying a complex building that's got irregular shapes.
Yes, exactly, Gillian. If we are here, as you can see in these drawings, we are only talking about rectangular shaped buildings. Imagine now if we are talking about some curved shaped buildings that were built a long time ago, or that we lost the drawings. It is really quite difficult to survey these kind of buildings. And I can imagine all the pain that we will have in order to try and survey this kind of complex and irregular shaped buildings. Here, I want to show you in a video, for example, even when we use a robotic total station, as you can see here, for example, even with a robotic total station, what we can also call a one-man total station, you can see the operator is holding the target, and he's manipulating the total station using a field controller. And he can position the target on the specific point, then hit the button on the tablet, and it will survey the point on the robotic total station. And even still, with this kind of very advanced and expensive technology, we are still surveying point by point. And if we ever miss any point during these operations, we need to come back to the site and do the surveying once again. So even with the most advanced technology, most advanced total station, if I can say, we are still spending a lot of time trying to surveying with this traditional method. And as you can see here, he still needs to position the target very well. Then he will need to check on the tablet and then press the button in order to survey it, and do it again and again for each point he wants to survey. So what is this solution that we are trying to promote and offer in order to solve these time-consuming operations? We are trying to offer a seamless workflow that goes from surveying to design directly and connect with the architectural workflows, because mainly we want to survey the existing building in order to design a new proposition or a new design for this existing building. So we are starting by the scan process. We are not surveying, we are doing laser scanning. And we are offering Topcon's laser scanner GLS 2000, which is really a high-end laser scanner, really good performance. We will talk about this laser scanner later. And then to do the post-processing, we are offering Recap Pro from Autodesk, which is quite a nice solution. It's not the best, if I can say, in the market, because there are other better solutions. I can talk, for example, about Magnet Collage from Topcon. I can talk about Context Capture. They are really performing very, very well as post-processing solutions, but they may be overkilling for building projects. These solutions that I have just mentioned may be better than Recap, but they are more suited for bigger projects. We're talking about road projects, dams, and bigger building projects. If I'm just talking about a building project, Recap Pro is more than enough to handle this kind of data and do the post-processing. Then, one interesting component that we will add is Edgewise from ClearEdge 3D that enables automatic object extractions. I will go through this solution later, but it is really an interesting step in this process and reduce a lot of time. And then at the end, of course, we are going to move to Revit in order to design and try to make a new proposition or a new renovation for the existing building. So let's start with the first equipment, Topcon GLS 2000. So Topcons offer this laser scanner in 3 different versions. Of course, 3 different ranges, short, medium, and long range. And each of them has a specific use, if I can say, depending on the range. And you can easily see the range varying from 130 meters to 500 meters. So it will depend on your projects or on your building projects. If you have a bigger building, you may move to medium or large. Or if you have a regular building in terms of size, short range may be enough to handle this kind of operation. And the EPA rating is 54. It is really, really high compared to other laser scanners available in the market. It is really rugged, made in Japan. It is made to last longer in the construction site, in the aggressive aggressive construction sites, as you know. So compared to other laser scanners who are not really resistant to dust and humidity and other aggressive factors, this one is really made for long-term laser scanning operations. It has a vision field of 360 degrees horizontal and 270 degrees vertical. And also there is an anti-theft system that is embedded, which is called TS Shield, that can offer some sort of geographic fence. For example, if you set it up, let's say, for example, I have it in Morocco, and I can set it up in TS Shield so that whenever it leaves Morocco, the equipment will automatically shut down and be locked. And I can also track it down whenever if it is stolen from the survey site, and I can easily find it whenever it is turned on. And there are also a lot of other features that are really interesting on the GLS 2000. One interesting feature is that there is a technology that is embedded in this laser scanner that reduce noise, which is really an important factor to compare between all laser scanners, and also multiple pulse, multiple laser pulse that this scanner offers. Let's imagine, for example, you have a tree and you want to scan a building that is behind these trees and the leaves are hiding some parts of the building. You can set GLS 2000's laser to higher pulses so that it can go through these leaves and penetrate them in order to attain and to target the building behind these leaves. So here there is a short video that promotes that Topcon has made to promote Topcon to promote GLS 2000. I'm sorry. So here, as you can see, Topcon offers a lot of surveying technologies, not only this laser scanner, but this one is the most suited one currently for our workflow. And it is really interesting. As you can see, it is rugged and compact. It may be heavy compared to other laser scanners, but it is normal because the material that they use to coat it, it's designed for more resistance, designed for shocks, and of course, designed for aggressivity of the construction sites. And as you can see here, it can be used right away. And of course, we can just mount it on a tripod and go ahead. And you can see the quality of the point cloud that we get from laser scanners, from this laser scanner. And it's quite handy once you get used to it. And there is a lot of applications that can be used to have as built of existing building, to do quality assessment of ongoing construction. We are going to talk about this later in another workflow, in another webinar. And it also can be used to do some specific check-ins or some specific inspections on existing buildings. So here, as you can see, it can also be used to produce deliverable of an existing building. You may have in some cases where a customer or an owner who is asking to deliver and restitute drawings of his existing buildings. I have witnessed an example in Algeria with a very, very big oil company in Algeria that owns some bases, let's say living bases for an oil station. We're talking about 1,000, 2,000 employees that are living in this exact area. And these buildings are really from 50 to 60 years ago. They don't have the drawings anymore, and they want to do the management of these buildings. So first they launched a tender where they were asking for traditional surveying for all these existing buildings. The majority of the replies were talking about 6 to 8 months of work in order to deliver this kind of deliverable. Then they were approached by one of our partners, and they approached them with the laser scan technology. We're talking about Topcon, of course. And then the customer launched again another tender, and this time requesting laser scan technology and not traditional surveying technology. And the delay went from 6 months to 3-4 weeks, which is really incredible and amazing. And you can see in this example how fast it can be with the laser scanner compared to the traditional surveying methods.
Nuruddin, if I may ask, is this laser scan technology only used for buildings, or can you use it for something else?
Very good question again, Gillian. Thank you. Indeed, we can use the laser scan technology for other projects. We're talking about bridges, dams, industrial facilities, oil and gas plants, etc. We can use it for many other applications, and it is still more or less the same process: scanning, processing, then extract or design with software. But it can be used, this laser scan technology can be used for other kind of projects except building. We are just trying here to promote the building parts because it is a vertical complex building segment.
Great, that's fantastic. And I've also heard that you would be able to save about 75% of your time using this type of technology.
Yes, exactly. That is really one interesting part we are going to get in right now, because with the workflow we are trying to promote and we are offering, there is a specific component that will really fasten the process by at least 75%. And we are going to cover this in the next slides. Thank you for this. So here about, if you want to, we need to talk about the post-processing part. Remember, we're talking about recap. So recap is quite simple and easy to use. You just need to do some really small introductory training, but it is really quite simple and easy to use. Where you can see here, for example, we have some interesting features as automatic registering or manual registering. And you can just drag and drop the scan data that comes from the laser scanner, and then you can just wait for it to be post-processed in Recap Pro. Then you can just get the result quite easily and quickly. Of course, we are talking about the building laser scan. If we want to handle some bigger data, I would strongly recommend to move to other solutions, as I said, magnet collage, for example, or context capture that offers some other features, of course, other than just doing the post-processing as Recap does, but also can handle bigger data and make it more fluid than what we can see in Recap Pro. So now to come back to my colleague's question, what is the current problem with the classic and current point cloud workflow? The main problem is that we can easily cut time to do the laser scanning, but when we come back to the office and try to do the 3D modeling on, for example, Revit, as you can see here, all the time that we gained with the laser scan technology, the fast scanning technology, we may somehow lose it when we try to model in a 3D model, because the 3D modeling will take a lot of time, because we need to import the post-processed data, post-processed laser scanner data, as you can see here in Revit, for example. But sadly, we need to model it manually on Revit, for example. And you start creating levels, then you will start adding walls, try to align to existing point cloud. And it is really like if you are modeling the whole point cloud building from scratch. Of course, you are using the point cloud data as a basic to generate the 3D building model, but it is still it may be inaccurate, because you need to be as close as possible to the point cloud result, and of course it is really spending lots of time. As you can see, for example, we move to a view plan, and here we are starting to model a wall, the exterior wall, for example, here, and we're just trying to do it as accurate as possible. As you can see here, it is really still time consuming, and it is really not as accurate as we want it to be. As you can see, for example, we have added columns here, and then as you can see, we moved to 3D model, and it is quite time consuming. So this is really one of the biggest problems or the biggest issues that the laser scan users are facing. They really gain a lot of time by using laser scan technology, but when they come to the office and try to model it, they lose all the gain time trying to have an accurate model, as accurate as possible. And of course, it is like remodeling again from scratch. As you can see here, we still have some alignment issues. We need to really check between 2D and 3D views and do it once again. So what we are trying to offer in order to solve this problem is the Edgewise solution. So my colleague's comment earlier was about Edgewise capabilities. As you can see here, it can complete more than half of the model with 0 man-hour. You just need to introduce the point cloud in Edgewise, have some settings, and then launch some routine commands that will go through all the point cloud and try to extract at least half of the model with 0 man-hour. And it can generate automatically 3D models by up to 75%. We're not talking about 100%. It may depend on the laser scan quality. That's why we are trying to recommend the best on the market, which is GLS 2000, of course. And it depends also on the post-processing, which is really important. So we have some quality assessment tools that can be used to compare the extracted object versus the point cloud used. We have some tools embedded in Edgewise that we can use to compare. There is some easy connect technology that can connect cylinders. We are going to see this, which is really interesting. And also object recognition technology for steel, concrete, windows, ducting, and other building objects. And what is really interesting is the 7th point, direct integration with Revit and export Edgewise model as a Revit family object, which is really, really helpful for building projects.
Thank you, Nuruddin. I have a couple of questions which have come through on the chat.
Yes.
One of them is, what kind of object can we extract automatically with Edgewise?
Okay, so Edgewise can extract multiple building objects. We are talking about, for example, if we're talking about architecture, well, we can extract windows, doors, walls, concrete columns, slabs, floors. So here, this is for architecture object. We can extract structural frame objects also. We're talking about steel frame objects, I-beams, and other kind of structural frame. And what is interesting also in Edgewise is that there is some pattern recognition. You know that, for example, for steel frame constructions, we have somehow a repeated pattern across different directions in our steel frame project. And we can use this repetitivity in Edgewise to help it identify and quickly find similar pattern with similar steel frame elements. And this is really something quite interesting. Edgewise can also extract pipelines, which is really helpful for plant and MEP projects. And also it can extract ducts to a certain extent. Okay, so also to show you a little bit what we can do with Edgewise, as you can see here, for example. So there is some customer testimony, as you can see, that have already used Edgewise, and now they cannot imagine working without Edgewise. So this is an example of pipe extraction, as you can see here. And there is a tool that can automatically auto-connect pipeline parts that were hidden by, let's say, steel frame structure that were there during the laser scan. which is really, really interesting for laser scan technology. So here, as you can see, for example, we have extracted a first pattern of steel frame, and we can ask Edgewise to look for similar pattern and try to extract it on both directions, as you can see. And in few clicks, you can easily extract this kind of technology. So it can also be used for ducts, as you can see here. This is quite an example also. And here we can see the application on a specific example. We just select the whole column, steel frame column. Then we ask Edgewise to try to extract on both directions from the point cloud, which is really, really something quite impressive, quick, and interesting.
Nuruddin, we have a question from Olusopo Olsupo, and he's asking, can this also be used to note objects in the substructure of the buildings or projects such as pipes and underground drainage?
Okay, this is a good question. Thanks for asking it. You need to know that laser scan technology cannot penetrate underground. So everything, laser scan can only scan and survey what we can see with the naked eye. Everything that is, for example, buried or buried underground, or let's say, for example, steel rebars in a concrete element. Unfortunately, we cannot use the laser scan technology. There is another kind of technology that can be used, which is georadars. The radars that can send some waves, ultrasonic waves that penetrate this element, if we are talking about a reinforced concrete element, or penetrate the ground, if we are talking about underground networks. Then the wave will bounce and come back to the equipment, to the radar. And of course, the propagation speed of this wave will depend on the material that it has penetrated. And of course, whenever it goes across other kind of material, for example, pipes, it will have different propagation speed. And with this, the georadars can identify what is the exact depth of this network and what is the criteria, the size, the diameter, etc. So it is really another kind of technology that is used. We cannot, unfortunately, use laser scan technology to get this kind of result. So I hope it answers the question. Can it also be used for plumbing pipes? As long as we can see it, yes. If the plumbing pipes are exposed, let's say, for example, we have let's how we call this. I'm sorry, I'm not a native English speaker, so sometimes I may have some difficulties with technical English words. Let's say, for example, if your pipes is hidden behind walls, unfortunately we can't. But if your piping network or plumbing pipe network is just laid on the construction phase, the execution phase, we can just come right when it is laid down. Then we can just scan it quickly as long as we can see it. And of course, we can have it back again in the Edgewise and do the extraction automatically.
Thank you, Nuruddin. Samuel is asking, will this scan give interior details of the building in Revit, for instance?
Yes, as long as we are talking about regular building objects, as I said before, we are talking about windows, doors, interior walls, slabs. We can have these objects as object families in Revit. But if you are talking about furniture, desk, chair, etc., this may not be extracted. And of course, the most interesting part when we do a laser scanning of a building, we are not really interested by the furniture. We are more interested by the fixed elements. We are talking about walls, windows, and floors. And of course, this can be extracted automatically with Edgewise and goes to Revit. And we are talking about interior and exterior details of a building. I hope this.
Claudio would like to know if it's possible to combine data from two devices when you're in a large building?
Yes, and if we are talking about two different laser scanners, it may be possible to a certain extent, depending on the parameters. You know that, for example, in GLS 2000, the data can be automatically geo-referenced. We can position our laser scanner to a known point. Then in the laser scan, we can specify the exact coordinates of this point. Then, of course, where the scanner will do automatically a laser scan, and all the results will be geolocated with georeferenced. There are some other laser scanners that exist on the market that doesn't have this feature. We need to come back to the office, do the georeferencing manually on ReCap or other solutions. Then we can combine those two data as one result. So it can be done, but it depends on how, what kind of equipment. Of course, if we are using the GLS 2000, this is obvious. It is georeferenced whenever we do the laser scan, as long as we have known points before each scan. And then when we go back to the office, we can automatically combine all the data in one result. Now, if we're talking about two different technologies, let's say we want to combine laser grammetry and photogrammetry. We want to combine drone pictures or drone photos with laser scan data. Unfortunately, this may be difficult to be handled with the ReCap, and I would recommend a better solution, which is magnet collage or context capture, if I can say, that can combine pictures coming from a drone. Let's say we are talking about the Sirius Pro from Topcon or the Falcon 8 Plus, and then we use the GLS 2000 to do some laser scanning. We can combine those data in these kind of solutions. So here you can see, for example, the limits of what we can do with ReCap Pro.
There's another question from Idris from Nigeria, who would like to know if there's anything you can discuss about any new tools that are available in Autodesk AutoCAD.
Okay, so this is another subject. We have already delivered a webinar on AutoCAD. We will have another one in the next week, if I'm not wrong. That will cover new features on AutoCAD 2020, and of course we'll try to cover our new features in AutoCAD on the last 2 or 3 versions. But it will be answered in another topic, in another webinar.
Thank you.
Okay. To move forward, I will try to move forward in this presentation, and of course come back again and answer all the asked questions. So here, as you can see, Edgewise is really powerful to extract objects automatically from point clouds. Again, it depends on the quality of your laser scan. If it is not really well scanned with good accuracy, it may not give you a good result. And this is, again, depending on the laser scanner. If you are using a Chinese brand laser scanner with really low accuracy, or other laser scanners with a bad accuracy setup, you may get some weird result, and maybe Edgewise cannot extract objects. So here, as you can see, the last piece of our process is the design part, where we are moving from laser scan to Revit. And you can see, for example, we have done some laser scan, and we can, as you can see in this example, extract automatically from Edgewise, then move to Revit, and of course, load the project that was created by Edgewise directly into Revit. Here we have loaded the point cloud, if you want to do the comparison. And here, as you can see, we have loaded also the 3D model that has been extracted by Edgewise. You can see here, we have an Edgewise tab that has been added. There is an add-on that we can install on Revit. And with this, we can open exported model from Edgewise directly into Revit. As you can see here, the extension is, the format is quite different. It's .c3 RVT, so to say clear edge to Revit. And here we can see there is some settings to handle. Then when we successfully import this model in Revit, you can see the result is quite interesting. And we have some families that has been automatically added, as you can see here, that has been generated by Edgewise in order to fit into a Revit model. And it is really, really quite satisfying as a result. So this is really the interesting part, is that we do not spend a lot of time anymore trying to generate a 3D model from point cloud. We can use Edgewise to help us extract as much as possible from the point cloud data. Then we just come back to Revit here with almost 75 or 80% of the 3D model already generated. And we can just complete the rest quite easily in Revit. It's really a lot of time gain compared to what we can do on the regular or classic laser scan workflow. So here there are some useful links that we will share with you after the webinar. The first one is about some tips and tricks for a successful reality capture workflows. What are the mistakes that you need to avoid in order to have high quality laser scan? So remember, I said that the extraction will depend on the quality of the laser scan. If you are using, and here we can see in this webinar on tutorial, some tips and tricks to avoid and mistakes to avoid when laser scanning. The second link is about how to extract structural elements with Edgewise. It's also a nice tutorial to follow. And the third one is the best practices for scan to Revit, if I can say, workflows. So from laser scanning, it is somehow resuming all the webinars I have explained. And of course, it shows step by step how to move from laser scan data to Revit. Also, upcoming webinars, we will have some follow-up webinars following this one. The first one will be a little bit detailed. We will go through some demonstrations on Edgewise, so how to do automatic extraction on Edgewise. And also another webinar that will show how to move from Edgewise to Revit. So how to export family objects. We will go through the software. It will not be as this webinar, which is kind of introductory. The other webinars, we will go in details. So thank you for the time that you have spent. I hope it was really interesting and it gave you a lot of information. We have some poll questions that we would like to ask you, and of course ask for your feedback. And in the meantime, I will try to answer the questions that I see in the chat. So if my colleagues can, we'll start the poll questions right now. You can see it, it will pop up in your screen. If you can please answer these questions, it will help us a lot improve ourselves and improve our content. Thank you.
I am launching the poll questions right now. Thank you.
So you can see the first question, what job do you have on a building projects? So you have multiple choice, architect, surveyor, structural engineer, contractors, or others. The second question, are you familiar with the scan to beam concept? The third one is, have you come across point cloud data using a building, during a building projects? So if it is yes, only once, or yes, in many projects, or you have never came across point cloud object or point cloud data. The fourth question, what software do you use in your job? AutoCAD, ArchiCAD, Revit, Civil 3D, or any other solutions? And the last, the fifth question, what survey equipment are you aware of? total stations, theodolite, levels, laser scanners, drones, GNSS receivers. And the last questions, would you like one of our local resellers to contact you? And you can check the multiple choice for more information, for a quote, or one-on-one demonstration with a local reseller. We would like to appreciate your honest answer. And of course, it will help us improve our content and our presentations in the future.
I'll keep the poll open for a few minutes just in case there are any more attendees that are busy answering the questions of the poll.
Thank you for that, Zoe. Also, I see a question that is still open on the chat. How extensive is the application in terms of surveying a large area? Maybe the need of aerial capture. I think I have quite answered this question while explaining how to combine other kind of data. You are right. When we are trying to cover a large area, the laser scan technology may not be enough. And of course, we need to combine it with photogrammetry, and of course, the need to use drones. On this subject, Topcons offers some really professional drones that can be used. We're talking about Sirius Pro, that is really professional and outperforming drone. And there is also another drone, an octocopter, that is called Falcon 8 Plus, that is equipped with a Sony camera. It can take pictures, of course, ortho photos. We can take them with the Sirius Pro. The Falcon 8 is also designed for this kind of photogrammetry, but it can also be used for example, we're talking about inspections. You have a high building, you have a dam, and you have some specific places you want to inspect. You can just fly the Falcon 8 Plus and face it to the dam and take pictures with the drone. It is using the photogrammetry, and of course we can combine both data coming from laser grammetry and photogrammetry and have one single result. I hope this answers your questions. So there's another question about Edgewise. On the automation, is it possible to link to Keystone family library? This kind of question, we will answer them in the upcoming webinar where we will do the extractions. By default, Edgewise doesn't offer you this possibility, but there are some tricks behind that we can use to do something like that. Let's say, for example, you have already created a custom family in your library, and you want Edgewise to use this specific library and not any standard library or a library that Edgewise has. There is a way we can show it in the upcoming webinar. Thank you.
Nuruddin, there's a couple of other questions that have come in from Claudio.
Is the computer graphic also important for the scan quality? To be completely honest, it does only matter from the graphical side when you want to see the result, but it doesn't influence the extraction routines, because it's not related to what you can use screen your screen. Edgewise will run some extraction commands or extraction automation routines that are only dependent on the exact coordinate of each point in the point cloud. So let's say, for example, if you want to extract a wall, Edgewise will try to look for a group of point clouds, objects, or group of points in the point cloud that have the same, almost the same Z, almost the same X or Y coordinate. And of course, they are only varying on two directions. And of course, if we try to describe it, this is the exact definition of a wall. We have a wall, it means that it's a group of points that have similar X, and they are close to each other, if I can say. I'm just trying to make it as simple as possible, but there are some specific routine checking that are embedded in Edgewise that can run this checking on all the point cloud object and check for similar points that have this kind of criteria. Then it can extract the wall quite easily. So it doesn't depend on the graphics, and of course it only depends on the processor, on the microprocessor on your computer, and the memory, the random memory that you have on your computer. It's not really depending on the graphical part.
Thanks, Nuruddin. We're going to leave the poll open for just a few more seconds. We've left it up so that if there's anybody further that's wanting to make some comments on the poll, please do. If there's any more questions. Great. If there's no more questions, please feel free in the next few seconds to ask any, if you have any. But I'd like to say thank you to everybody for joining the webinar today. I hope it's been insightful, and I hope that you've learned some tricks and tips from Nuruddin regarding the workflow that we've presented. We will be sending a copy of this webinar out to all the attendees, and we will have contact details on there. If there's any questions that you may have, you please feel free to send those through to us. We'd be happy to chat to you about those. We've got, Ayobami's just asked if the webinar is going to be available offline. Yes, it will be, and we will send that link out to you. If there's no other questions, once again, thank you very much. Have a fantastic day. We look forward to working with you in the future.
Thank you again. Thank you everyone for attending, and thanks to Gillian and Zoe.
Thank you, Nuruddin. Thank you, everybody.
Bye.